Completing the square is a type of solving a quadratic equation that requires you to understand how to take the square root of both sides. So it's a more complex problem than something like this, x squared equals 16. It first makes you get it into this kind of equation. So it asks you to figure out what number you need to add to fill in this blank. It's a different method than factoring or using the quadratic formula. It's just a different option. So for example, if you have a problem like this, x squared minus 6x plus 5 equals 0, I would first check to see, does it factor? It's already equal to 0, so check it out, see if it factors. In this case, is there a number that multiplies to 5 and adds up to negative 6? Yeah, x minus 5 and x minus 1. In which case your answers are x equals 5 and x equals 1. So I would choose factoring for that one. For this problem, you have a leading coefficient that doesn't lend itself to completing the square very easily. So I would not choose completing the square for something with a leading coefficient such as this. I would next look to see if factoring is an option. 3 times negative 8 is negative 24. Negative 6 and positive 4 do not add up to negative 10. Negative 12 and positive 2 do add up to negative 10, so I would try, or I would factor this using the AC method. And your answers are negative 2/3 and 4. Number 3, x squared minus 8x plus 5 equals 0. There's nothing that multiplies to positive 5 and adds up to negative 8. Because the b, the middle term, negative 8, is an even number, this lends itself easily to completing the square. You want to figure out, what can I add to both sides after I move the 5 to the other side so that I can factor this as a perfect square binomial? So what number needs to go here? I know it's going to be a negative because my b term is negative. So what number can go in here so that it becomes x squared minus 8x plus something? If I divide this by 2, that's kind of the trick. This becomes negative 4. And I square it, it's 16. And if I have x minus 4 times x minus 4, I'm just checking to make sure I got the right number. That's x squared minus 4x minus 4x plus 16. So that is x squared minus 8x plus 16. So that is x minus 4 squared. So it works. Whatever I added to the left side, I have to add to the right side. So this becomes x minus 4, the quantity squared, equals 11. So I have x minus 4 squared equals 11. Now that I have some quantity squared equals 11, I want to take the square root of both sides because I want to get rid of that squared part. On the left side, I have x minus 4 equals positive or negative square root of 11. I need the positive and the negative square root of 11 because I have two potential solutions. I need both possible answers. It could be the positive or the negative part. Then I need to add 4 to both sides. Because the 4 and the square root of 11 are not like terms, I cannot add them together. So it becomes x equals 4 plus or minus the square root of 11. That is my final answer. Here I need to figure out what I need to add to both sides to complete the square. So I'm going to use that little trick again. Divide by 2, you get 8. Square it, you get 64. 17 plus 64, 81. So now I have x plus 8 squared equals 81. Take the square root of both sides. Because you are inserting the square root on both sides, you need to account for both the positive and the negative part. Since you're taking the square root, you don't know if it was a positive originally or a negative originally. So x equals negative 8 plus or minus 9, which means it could be negative 8 plus 9, in which case it's positive 1, or negative 8 minus 9, in which case the answer is negative 17. Two potential answers. You could check your work by substituting 1 squared plus 16 times 1. Does that equal 17? Yep. And then I would have negative 17 squared plus 16 times negative 17. Does that equal 17? And it also does. I'm sorry. Okay. Last one. What do I have to add here to both sides? So divide by 2, square it. Negative 6 divided by 2 is negative 3. Negative 3 squared is 9. So if I add 9 to both sides, 35 plus 9 is 44. So I have x minus 3 squared equals 44. I take the square root of both sides. So it's x minus 3 equals the plus or minus square root of 44. I can simplify that. So it's x minus 3 equals plus or minus square root of 4 times the square root of 11. They're still not like terms, so I cannot add them together. So that is my final answer. So that's completing the square.